side, we have the static electricity that has to do with charges that don't move, and dynamic electricity that has to do with electrons that move. So when electrons begin to move from one point to the other through a conductor wire, we have dynamic electricity. And dynamic electricity is what we call current electricity. So when electrons move through a conductor wire, we call it current. So current is the rate of flow of what? Electric charge through a conductor wire. We now said we have a circuit. Circuit is the path, P-A-T-H, the road, the path provided for the travel of what? Electric current. And I gave you three types of circuit. The closed circuit, when the circuit is closed, current can flow. It's like you are saying you switch on the socket. We have the open circuit. When you have the open circuit, current cannot flow, like you switch off. And we have the short circuit, where you make current to flow in a short, and that usually causes shock at home. Short circuit. Now, when I say what are the things you find in a circuit, what are the components of a circuit? The components of a circuit are one source of current. Just what is? We have switch or what key that will control the flow, whether current will flow or it will not flow. Then we have what we call load or we call it resistance. Then we have voltmeter. If you watch, you discover that ammeter is not there. Why? Ammeter is just used to what? Measure the amount of current that is flowing. We have said source of current is flowing, we know. So if you put ammeter, it's just want to measure the quantity of current flowing. So the components of a circuit are source of current, switch, and source of current could be battery or cell. Now what is the battery and what is cell? What we call battery is this. This is the symbol of battery. So we are looking at symbols in electric circuits. Symbols. Now what is? Pay attention. When you have this is thicker, this is plus, the longer one is plus, minus. This is just what you call your cell. But when you now have this one, 2 or more, this one, this is 2, Abby, this is 3. This is what we now call battery. So you don't call your phone. Your phone is not having battery. Your phone is having what? How many did you see here? That's why it's called cell phone. When you connect batteries, cells, 2 or more cells, your tiger battery, you call it over. Connect 2 in your touch. That's why you now call it battery. But if it's 1, your own is called cell. Now this is switch. Switch or key. But there are different types. If I call this one, if I do something like this, you call this one tapping key or switch. But if I do it like this is called plug key. All of them are called switch. So this is the common symbol for switch. Now if you have something like this and put it like this, it is called galvanometer. I told you galvanometer is used to detect small current. Another galvanometer is this. G. So these are the things you will see, the symbols you will see in a circuit. If you have this like this is ammeter. But if you have this like this is milliammeter. Of course, if you add this, it is voltmeter. Now, if you add this like this, this is transformer. Now, if you add this like this, this is called bulb or load, bulb or filament lamp. If you add this like this, H is symbol of inductor. It's called airy. So this is an inductor. Now, if you add this is resistor. But if you now add something like this, this is called rheostat. Now this could be resistance. Normally we have it, but because we don't usually add this, it will be resistance. But if we now add something like this with R, we call it resistor box. So let's add this in our notes. So let's see some other shapes. If you add this, look at it, this looks like resistor or resistance. But look at it. This is called impedance. Now this looks like a cell, but you see that the two plates are equal. This is called capacitor. Now, if I have something like this, this is wire crossed. And we have this something like this. This is diode valve. So I've shown you cell and it depends between cell and battery. Show you galvanometer, meter, milliammeter, switch. All these are switch, the tapping key, the plug key. Then I've shown you inductor, resistor, box, rheostat, resistance, bulb or filament, transformer. Show you impedance, capacitor or capacitance, wire cross, diode valve. These are examples of symbols of some components of a circuit. Resistance or resistors are arranged in a circuit in two ways. Resistors are arranged in a circuit in two ways. One, series arrangement, and 2, parallel arrangement. Resistors are arranged in a circuit in 2 ways. 1, series arrangement. 2, parallel arrangement. Let's look at series arrangement. In series arrangement, 2 or more resistors are arranged such that the positive end of one resistor is connected to the negative end of another resistor, and the positive end of that resistor connected to the negative end of another resistor, and so on. In series arrangement, a resistor arrangement, the positive end of one resistor is connected to the negative end of another resistor, and the positive end of that resistor connected to the negative end of the next resistor, and so on. Like this. So we have this. If this is positive, pay attention. If this is positive, negative, then for this resistor, there is positive, negative. Watch me. The positive end of this resistor 1 is connected to the negative end of the resistor 2, and the positive end of this resistor 2 is connected to the negative end of resistor 3. And so on. Keep writing. The resultant resistance provided in the circuit, the resultant, that's the combined resistance. The resultant resistance provided in the circuit is given as 1 over R equals 1 over R equals R1 plus R2 plus R3. But that's not the point I want you to note. Watch what I will do. Watch this, please. This is where Jam will always ask you questions that will beat you. Watch, I want to connect something now. I will we'll take some notes. Watch what I will do. This is a circuit. Whenever you connect resistance or resistors in series, the voltmeter is usually connected in parallel to each of the resistors. But the current I flows this way. So I have my cell or my battery this way, positive, negative. Note that at the positive end, I told you the bigger one is the positive end, current flows out from that end. Now I will add a switch. I could add a switch somewhere here. And that is just a simple circuit. Now, what I want to say? Look at the current I. Look at it. It goes through this conductor wire. This current I, the same I, one single I, moves straight to R1. It enters the R1. The same current enters the R2. The same current enters the R3. But the voltage for R1 is different from the voltage for R2. Now is the point we need to note. In series arrangement, the same current flows through the different resistors, but different voltages. So in series arrangement, the resistors have the same current but different voltage. Now, write this.
I'm coming.
In series arrangement, one, the same amount of current flows through them. That is, in series arrangement, the same amount of current flows through them. That is, the resistors all have the same. The resistors all have the same current, the same value of current. The resistors all have the same value of current. Two, different voltages. Or as you say, the resistors have different voltages. The resistors have different voltages. And three, the voltmeter is connected in parallel to the resistors. The voltmeter is connected in parallel to the resistor. So this, you can put this in bracket. This is series arrangement. So what we'll see again in next class, we'll do work on the parallel arrangement.